Okay, so this is the review for second period's Module 2 Part 2 test. Remember, Module 2 has been really long. We've been working on Module 2 for like ever. Excuse me. Your test is only going to be over the stuff that we have learned since the first module test. I'm not putting the entire module on here. It would be too much stuff, okay? So it's only the things that we have learned since our last test. So that would be long division and synthetic division, and those problems are actually the last problems on the review by mistake. Multiplying and dividing rational expressions, adding and subtracting rational expressions, complex fractions, and expanding binomials. That's what's going to be on your test, okay? So everything that's on this review is going to be on your test. If it's not on the review, it's not going to be on your test. You come, we have a test on Friday. We're doing a review today. These, and take your earbuds out. Right here, 2 pages. No, those worksheets. All right, so let's look at the first section first. It's multiplying and dividing rational expressions. So I'll do one multiplication and I'll do one division. Let's do number 1. Perfect. If you need more of a reminder than what I'm giving you today, hey, I posted a video on Schoology of every lesson that we've done. So you can go back and watch that. Yes, there's videos. All right, so when we're multiplying, remember you multiply fractions, numerator times numerator, denominator times denominator. And also you want to factor anything that you can. Binomials, you don't have to, or monomials, you don't have to factor those. Anything else that you can factor, factor it. So let's look at n squared plus n minus 42. A is 1, we could probably do that in our head, right? Give me 2 numbers that multiply together to get negative 42 and add to get positive 7. Give me 2 numbers that multiply together to get negative 42. We'll start there. All right. 6 times negative 7 is negative 42. And 6 plus negative 7 is negative 1. We want it to be positive 1. What can we do? So negative 6 times positive 7 is negative 42. Negative 6 plus 7 is positive 1. Perfect. So we know n squared plus n minus 42 will factor into n minus 6 and n plus 7. And we factored enough to know I don't really have to do my T-chart and divide and slide. Now, if A is a 2, then I probably am going to still do that. But if A is 1, I can do that in my head. And then that's being multiplied by 1 in the numerator. We don't have to put that, do we? In the denominator, n squared minus 49. Isn't that a perfect square minus a perfect square? Don't we know a shortcut for factoring that? Yeah, and if we didn't, if we wanted to do T-chart divide and slide, what would A be? 1. What is B? 0. And C is negative 49. Okay, but if it's a difference of squares, we make 2 sets of parentheses. 1 always gets a plus in the middle, 1 always gets a minus when it's a difference of 2 squares. The first term in each set is the square root of the first term. What's the square root of n squared? N. The second term in each set is the square root of the second term, the absolute value of the second term. What's square root of 49? 7. And otherwise, we'd be looking for 2 numbers that multiply together to give me negative 49, add together to give me 0, negative 7, and positive 7 work, right? And then that's being multiplied by 8n on the other side. And since that's a monomial, I'm going to put that in the beginning. Now, we cancel what we can. Anything cancel? N plus 7. And that's it, right? So I'm left with n minus 6, quantity divided by 8n times n minus 7. If you wanted, you could put n minus 6 divided by 8n squared minus 56n, either or. The answer sheet leaves it in factored form. But it's not wrong if you distribute it. And it also said state the excluded values. Remember, the excluded values are what can n not equal. If it equals that number, it's going to give you a 0 in the denominator. So look at our, before we've canceled anything out, from 8n, what can n not equal? 0. From n plus 7, what can n not equal? -7. And then also from the up from n minus 7, 7. So my excluded values are -7, 0, and +7. Leo? When is our test? Friday. If you're not going to be here on Friday, please, please, please tell me and be ready for the test Wednesday. Otherwise, you're going to wait till you come back and, you know, if it's an unexcused absence, it will not be a multiple choice test. And we're leaving for vacation early is usually not an excused absence. Just so you know. All right, any questions on that one? Okie dokie. Let's look at number 2, is dividing rational expressions. So number 2, I'm going to write that on my paper. And I can't remember if we've had any Khan Academies to do since our last test. I'm not sure, I'll have to look, but if so, make sure yours is done. I'll look. Okay, so remember, when you are dividing, you have to, first of all, change it to a multiplication problem. I would do that first, because if you go ahead and factor, usually by the time you get everything factored, you forget, oh, I never did that whole keep, change, flip thing. So do that first and then factor so you don't forget about it. So remember, when you're dividing rational expressions, you keep the first fraction the way it is. You change the division to multiplication, and you find the reciprocal of the second fraction. Now remember, that 5 minus r was once in the denominator. So when you say your excluded values, you have to take the 5 minus r into account, because at one point it was in the denominator. So sometimes it's the same excluded value that you would get from the other fraction anyway, but sometimes it's not. So you got to remember that. All right, so let's see if we can factor. R squared plus 5r plus 4, a is 1. We can do that in our head. Two numbers that multiply to get 4, add together to get 5. 4 and 1, 4 times 1 is 4, 4 plus 1 is 5, that works, right? So I'm going to factor the numerator of the first fraction to r plus 4 and r plus 1. You can't do it in your head, no problem. You know how to do your T-chart and all that mess. And then 5 minus r cannot be factored. Ooh, but you know what? Wish I wasn't writing in pen. I'm going to want to rewrite that in standard form and then possibly factor out that negative, because I might be able to cancel it out. But I'll do that in the next step since I'm writing in pen and forgot. Okay. Denominator of the first fraction, two numbers that multiply together to get -5, add to get -4. All right, let's see. -5 times 1 is -5. -5 plus 1 is -4. That works. So we have r minus 5 and r plus 1. And there's no a, so I don't have to worry. I mean, a is 1. There's an a, it's just 1. So I don't have to worry about divide and slide. And then the other denominator is 1. We don't have to multiply by 1. Now, see, at this point, it just looks like the r plus 1 cancels, right? But like I just said, that 5 minus r, I need to rewrite that as -r plus 5, which that doesn't cancel with anything either. But then let's factor out that -1. So if I factor out a -1, wouldn't I have r minus 5 in the parentheses? And that's going to cancel with something. So I'm going to rewrite my problem as r plus 4 times r plus 1. I'm going to put a -1 in its own parentheses because I factored out a -1. It did not go away. And then r minus 5 all over r minus 5 times r plus 1. So if we would not have done that, we would not have realized that we could cancel out another factor. You know what I'm saying? So now we can cancel r plus 1 divided by r plus 1, r minus 5 divided by r minus 5. So in the numerator, I have r plus 4 times negative 1. Well, I'm going to write the negative 1 first because it's a monomial. And I don't need to write the 1, just the negative sign. So negative, open parentheses, r plus 4, quantity divided by, oh, we only have a 1 in the denominator, right? So we don't even need to write that. So you could either write your answer as negative, open parentheses, r plus 4, or you could say, you could distribute the negative and do negative r minus 4. And on the answer sheet that I'm looking at, that's the way they have it written. A lot of lag time today, sorry. So excluded values, r cannot equal. Remember the 5 minus r was at one time in the denominator. So for 5 minus r, what would r have to be to give me a 0? 5. That's 5 minus 5, 0. So we know r cannot equal 5. And let's go down to our factored form. R minus 5, well, it can't be 5. We already have it listed. And with r plus 1, it can't be negative 1. Right. Whatever's going to turn it into a 0. That factor. It's easy. It just gets a little confusing when your coefficient of your variable is not 1. Then you might have to put a little bit more effort into it, but otherwise it's pretty easy. Okay, so that's multiplying and dividing rational expressions. Cool beans? Your next section is adding and subtracting rational expressions. Adding and subtracting. So let's do number 11. Eleven is 5n divided by n plus 2 minus, and I like to write mine horizontally or vertically, I always say that wrong, minus 4 divided by 3n plus 9. And I'm going to go ahead and factor that, although it really doesn't, it's not going to make a difference here, but let's just in case. If I factor that, that would be 3 times the quantity of n plus 3, right? All right, we cannot add and subtract fractions until we have a common denominator. So I've got 3 factors here. 3 is a factor, n plus 3 is a factor, n plus 2 is a factor. What's my least common denominator? What's the monomial of my least common denominator? 3. And then I'm going to need an n plus 2 and an n plus 3, right? And me factoring out that 3, it really didn't change anything. But say when I factored out the 3, what was left in parentheses was n plus 2. And then I would only needed a 3 and n plus 2. But in this case, it didn't change anything, so it wasn't necessary. But we're used to be factoring. Okay, top fraction. What am I missing? I have n plus 2. N plus 2 times what gives me 3 times n plus 2 times n plus 3? Y'all not know, or you just do? Top fraction. I'm gonna have to make equivalent fractions, right? So n plus 2 times what will give me my new denominator of 3 times n plus 2 times n plus 3? 3 and n plus 3. Good. Okay, so I'll go ahead and multiply those monomials together. 5n times 3 is 15n times n plus 3. And then I'll multiply those together in my next step, okay? Bottom fraction, 3 times n plus 3 times what gives me 3 times n plus 2 times n plus 3? Just an n plus 2. That's the only one we're missing. Now remember, I am subtracting the denominator. So when I distribute, just think of it as distributing a negative 4, okay? So think of that as distributing a negative 4. So negative 4 times n is minus 4n. Negative 4 times positive 2 is negative 8. Now when I bring that, what I have written in red down, I am going to go ahead and distribute. So I get 15n squared plus 45n minus 4n minus 8. The denominator, do not multiply all of that out. You might be able to cancel something, so leave it in factored form. My numerator, let's see, in standard form, I have some like terms. That would be 15n squared. 45n minus 4n would be plus 41n minus 8 all over 3 times n plus 2 times n plus 3. Now, does that numerator have a GCF? No. And to factor it, I would need two numbers that multiply to get whatever 15 times negative 8 is and add to get 41. I'm looking at the answer sheet and I know that it can't be factored. But if it could, I would need to factor to see if I could cancel anything out. Okay? So this is the way that your the answer is given on the answer sheet. And this section did not ask for any excluded values, so this is my answer. I noticed some of you, when y'all had this for homework, you would give me your answer as 15n times n plus 3 minus 4n minus 8. It either needs to be all factored or in standard form, one or the other. Not some things being factored and some things not being factored, either all factored or all in standard form. All factored means you only get, everything's being multiplied together. Julio? Let's do number 15. Oh, that's a subtraction one. Let's do 18. On 18. We didn't necessarily have to on that one. It didn't make a difference. Sometimes it will make a difference as far as reducing goes. Okay, before I get common denominators on this, I could probably factor 3k squared minus 3k minus 36. I know there's at least a GCF of what? 3. Let me do this over here on the side so I'm not rewriting everything. Figure out what my factors are. So I'm going to factor out of 3. And that would leave me with k squared minus k minus 12. So I have a quadratic. I would need two numbers that multiply together to give me negative 12, add to give me negative 1. Two numbers that multiply to give me negative 12 and add to give me negative 1. Nobody has an idea? Positive 4 or positive 3? Negative 4 or positive 3. So it should be 3 times k minus 4 times k minus 3. Negative 4 times, oops, positive 3, I'm sorry, k plus 3. Negative 4 times positive 3 is negative 12. Negative 4 plus 3 is negative 1. Okay, so I'm going to rewrite my problem, and I'm going to have that in factored form. For my LCD, the least common denominator, tell me what the monomial part of the LCD is going to be. 3, 3, k, 3k. So 3k, and I'm going to need a k minus 4, and I'm going to need a k plus 3. Let's do that bottom fraction first. For my denominator, what piece of the denominator, which factor is missing? For the bottom one. Just a k, right? I got the 3, I have a k minus 4 and a k plus 3, but I don't have that k part. So I'll just need to multiply it by k. So when I do, I'm adding 5k squared. Well, the top fraction, I've got the 3k already. The factors that are missing are k minus 4 and k plus 3, right? So if I multiply the denominator by k minus 4 and k plus 3, I need to multiply the numerator. And I caution you, multiply the binomials together first before you distribute the 2k. Because if you distribute the 2k to both sets of parentheses, you're over distributing and it's going to be wrong. Just multiply the binomial together first, and then we'll go back and distribute the numerator, okay? So I'm going to have 2k times, well, we already know that k minus 4 times k plus 3 is k squared minus k minus 12 because we just did the math over on the right side of our paper, right? So k squared minus k minus 12. So now I can add my fractions together, add the numerators together, and then bring down the denominator. So when I no, because I already had a 3 in the denominator. I was only missing the k part of 3k, okay? All right, so when I bring that red part down, I'm going to distribute the 2k now. So 2k times k squared is 2k cubed. 2k times negative k is negative 2k squared. 2k times negative 12 is negative 24k. Over, oops, I forgot. And then I have to add 5k squared. Do not multiply your denominator out. You might be able to cancel or reduce something. That numerator, I have some like terms, okay? So, and I need to write it in standard form. So it'd be 2k cubed. Negative 2k squared plus 5k squared is plus 3k squared minus 24k all over 3k times k minus 4 times k plus 3. Now I can see I have a GCF of what? k. And if I factor it out, the denominator, there's a k in the monomial, I'll be able to cancel those or reduce them, right? So I'm going to go ahead and factor out a k from my numerator. So when I do, I get 2k squared plus 3k minus 24 all over 3k times k minus 4 times k plus 3. I just factored out a k from the numerator. Now, I might be able to factor that quadratic. I would need two numbers that multiply together to get negative 48 and add to get positive 3. I don't think there's anything that I can multiply to get negative 48 and add to get positive 3. Is there anything else I can do? Is this my answer? Isn't there a k in the numerator and a k in the denominator, and they're both monomials, which is what I just said we would cancel if we factored it out? So is there anything else I can do? Yeah, I gotta cancel out these k's. They're both monomials, so I can do that. So I'm left with, in the numerator, 2k squared plus 3k minus 24 quantity divided by, don't forget, you still have that 3 times the quantity of k minus 4 times k plus 3. And again, it did not ask you to state any excluded values. If you still struggle with adding and subtracting rational expressions, I would suggest you either go back, if you're absent for sure, go back and watch my video that I posted in Schoology, or also go to YouTube and search adding and subtracting rational expressions and get a whole bunch of other videos that other people have posted. Uh-huh. Uh-huh. Okay, so go back up to the top. Remember we had 2k times k minus 4 times k plus 3, right? So I made k minus 4 times k plus 3 with k squared minus k minus 12 as we just did that earlier. So I multiplied these together first to get k squared minus k minus 12. And then when we came down here, then I went ahead and distributed the 2k. 2k times k squared, 2k cubed. 2k times negative k, negative 2k squared. 2k times negative 12, negative 24k. I just did it in steps. Okay, one factor, because I had to figure out what my LCD was, so I factor everywhere I can. And so once I figured out what I need to multiply by, and then I was like, well, I already know what k minus 4 times k plus 3 is, because k squared minus k minus 12 gave me those factors. If I did it, I would just say k times 6, k squared, k times 3 is 3k, negative 4, and then I had to combine my terms. Okay? Okay. Next thing we have is complex fractions. I feel like complex fractions is what gave y'all the most problem of anything. Complex fractions and then adding and subtracting, okay? Complex fractions. That is 21 through 30. And when I grade your test, I'm going to divide it up into sections. So you're gonna see like 5 different grades for your test, 5 grades. It's the same amount of points as it would be if I did not divide it. But say I'm going to have like a section on dividing, a section on multiplying and dividing rational, a section on adding and subtracting rational, a section on a binomial theorem. And so each one of those will have its own separate grade. So that way, say you did great on the whole test, but you failed complex fractions, you did bad on that, and you want to retake it. I'm not going to make you retake the whole test. You would just retake the complex fractions part. You know what I'm saying? But it will not be multiple choice. If you retake something, it won't be multiple choice. So if you need to retake the whole test will not be multiple choice. Coolio? So you want to do well the first time around. But you will have the opportunity to do so. Because remember, there is not any credit recovery this year. Right? Okay, let's do let's do 22. And remember, your handwriting can be your own worst enemy on these. You want to make sure you write very legibly. I'm guilty of it myself, trying to squeeze stuff in. So a complex fraction is when you have a fraction within a fraction. And you don't want that. You just want one regular old fraction, okay? So to get rid of the fractions within the fractions, we have to multiply every fraction or even whole number or just regular old expression by the least common denominator. Okay, on this one, we have two monomials, a 4 and a 3. So what's the least common multiple between those? 12. So 12 is going to be part of my LCD, right? And I'm also going to need a x plus 4 and an x minus 2. So it's probably going to be a little crazy. All right, so let's multiply each piece by 12 times x plus 4 times x minus 2. And remember, when you do that, that's in the numerator of each fraction. This one's going to be a little crazy. So first thing I'm going to do is I'm just going to go cancel and reduce where I can. So let's see the top right. X plus 4s will just cancel out nicely, right? Bottom right, x minus 2s will cancel out nicely. Top left, the 12 and the 4 do not cancel out, but they reduce. What is 12 divided by 4? 3. Or you can think of it as 4 divides into 4 once, 4 divides into 12 3 times. So that 12 will turn into a 3. Bottom left, again, 12 and 3 don't cancel, but they reduce. 3 divides into 3 once, 3 divides into 12 4 times. So now all of those individual fractions should have canceled or reduced to 1. Okay, if they didn't, then you didn't pick, you might have chosen a common denominator, or you might have chosen, you didn't choose a common denominator if they didn't all cancel out. 12 and 4 just reduced. 12 reduced to 3, 4 reduced to 1. You need to scoot up. Plenty of seats up front. Hello. Good, how are you? Oh, that's okay. Yes. Thank you. All right, so now each of those different fractions that are left, we need to go multiply it all out and then combine it and see if we can factor it, okay? So top left, I've got 3 times x minus 4 times x minus 2. Y'all can set this up however you want to. I'm going to try to, like, over here on the side, I'm going to do the 3 times x minus 4 times x minus 2. I don't want to do like each step and write the whole problem over for each step. So 3 times x minus 4 times x minus 2. Don't distribute the 3, distribute your binomials first. So that's 3 times x squared minus 2x minus 4x plus 8, which is 3 times x squared minus 6x plus 8, combining like terms, right? Then I'm going to distribute the 3, so that's 3x squared minus 18x plus 24. So that top left fraction, all of that simplifies to 3x squared minus 18x plus 24. Oh, you're right. Darn it. Yeah, it's supposed to be x plus 4. Thank you for pointing that out. So I did x plus 4 is on the right side, and I changed I did x minus 4 and x plus 2 when it should have been x plus 4 and x minus 2, right? So x plus 4, x minus 2, x plus 4, x minus 2. So then that's going to change some things over here. It should be x plus 4 and x minus 2. So that's going to be x squared minus 2x plus 4x, which that's going to be x squared plus 2x. Why couldn't I use my erasable pen for this part? So that's 3x squared plus 6x plus 24. Oh, thank you. So 3x squared plus 6x minus 24. Thank you for catching that. Hopefully I've not now thoroughly confused everyone. Right, cool with that? Blender. Okay, so now I am subtracting whatever is left in that top right fraction, not just the first term, everything that's left. So I'm going to go ahead and open a parentheses or a bracket or something up there, because I'm going to need to distribute that negative. If there's more than one term, I have to distribute the negative. So we have on the top right 4 times 12 times x minus 2. Well, 4 times 12 is 48. And then I'll need to distribute that to the x minus 2. So I'm going to do that over on the side. So 48 times x is 48x. And what's 48 times negative 2? 96. Top right. Joseph, you have your phone out. Just asking. So you see, if I didn't put that bracket there, or I could have used the parenthesis, I would have only ended up subtracting the 48x. When I'm subtracting that whole second fraction, not just the first term. So I'm going to have to distribute that negative, but I'll do it in the next step. Y'all cool with that? Okay. What a mess. Denominator. Okay, Joseph, I'm doing the bottom left first. So I've got a 4. Goodness, this one's going to be fun. 4 times x plus 4 times x minus 2 times x minus 2. Okay, definitely going to do that over on the side. So I have a 4 times x plus 4. And you know what? I have x minus 2 times x minus 2. I'm going to do that as x minus 2 quantity squared. And I'll multiply those together first, because we know a shortcut for that. That'll at least save us some time, right? Is that 2 x minus 2s? You know what I'm saying? Okay. So I have 4 times x plus 4 times binomial squared. We know a shortcut. First term is the first term squared. So that's x squared. The middle term, you multiply the first term and the last term and double it. So x times negative 2 is negative 2x. Double it or multiply it by 2, and that's negative 4x. Your last term is the last term squared. Negative 2 times negative 2 is positive 4. Okay, that saves us a little bit of time. Now we'll have to multiply that with x plus 4. And we could do the box method, or we could distribute. I might as well just distribute. So 4 times x squared is x cubed. X times negative 4x, negative 4x squared. X times positive 4 is positive 4x. If I make a mistake, you'll tell me sooner than later. Distribute the 4. That's plus 4x squared minus 16x plus 16. So if I had this problem on my test, I would probably skip it, do the rest of the problems, and then come back to it later. Because this one would take up a lot of time. And just in case you don't want to, you know, spend 25 minutes on this problem and not do the others. So we have 4 times, let's see, the x cubed minus 4x squared and plus 4x squared cancel. 4x and minus 16x make minus 12x. And then plus 16. Now I'm going to distribute the 4. 4x cubed minus 48x plus 64. So that was that bottom left fraction, all multiplied out. I get 4x cubed minus 48x plus 64. And then again, I'm subtracting whatever that bottom right simplifies to. So again, I'm going to use parentheses or brackets, okay? Because I'm not just subtracting the first term, I'm subtracting however many terms there are. So let's see if we can do this in our head. We know we have 9 times 12. And that is 108. And then we'll distribute the 108 times x plus 4. So 108 times x is 108x. And then 108 times 4. Okay. And that is a plus. I'm sorry I gave y'all this problem. Jeez, try not to give you one that's crazy on the test. Okay, well now it's simplified a little bit more. So in that numerator, let me get rid of those brackets by distributing the negative, and I'll do the same thing in the denominator. In my numerator, I'll combine like terms. So I get 3x squared minus 42x plus 72. And in the denominator, I get 4x cubed minus 156x minus that's a 432. Minus 432. That makes a difference. I wrote it down wrong. So 64 minus 432 is minus 368. Now, the answer sheet does not have, it has it as this. So I'm assuming nothing can be factored, or if it can, nothing will cancel out. So we're going to be done with this problem. That was a doozy. Coolio? So I'll try not to give you any that complicated. And you know, as Avril Lavigne says, why does everything have to be so complicated? See the way. Okay, expand binomials. That's what you had, what I taught you last class. That's the binomial theorem and Pascal's triangle, right? I am not giving you Pascal's triangle on the test. You have to do Pascal's triangle. You have to know it yourself. So which one of those do you want me to do? 31, 32, 33, 34. 34, okay. So 3b plus 1, okay, and that's a b. Make sure, be careful that your b's do not look like 6s or you'll mess yourself up. Pascal's triangle, what's the number at the very top? And then, no, 1, 1. 1 and then 1, 1. Okay, and then what, Jeremy? 1, 2, 1. And then 1, 3, 3. Yes, always the one on the outside. Can we stop here? Is this the one we need? No. Do another one. We have 1, 4, 6, 4, 1. Do we need another one? No. This is the row we need, right? The second number is the same number as our exponent. And what are those numbers from Pascal's triangle? But what do they tell us about our answer? They are the coefficients of each term. Very good. So I'm going to have 1, 2, 3, 4, 5 terms, and these are the coefficients. I'm going to write them far apart. 1, 4, 6, 4, 1. And remember, when we're expanding using the binomial theorem in Pascal's triangle, we're figuring out what 3b plus 1 times 3b plus 1 times 3b plus 1 times 3b plus 1 is without doing any of all of that distributing, right? So to start with, you take your first term, 3b, the whole thing is raised to the 4th power. If you just put 3b to the 4th, that's not right because the 3 is also being raised to the 4th power. And then you go down, 3b quantity cubed, 3b quantity squared, 3b quantity to the 1st, and the last term is 3b to the 0, which is 1, so I don't even put it. Then I go to the plus 1 part. That's the second term of the binomial. And I'm going to put that on the very end and raise it to the 4th power. Then I'm going to go backwards to the 3rd, to the 2nd, to the 1st. And then my first term does not get the last term. All right, first of all, let's look at that first. Everything's positive. 3b plus 1, it was all positive, so there's not going to be any negatives in this problem at all, right? If that second term's negative, then you take that into consideration when you're writing it in the problem. So what is 3 to the 4th power? It's 81. Do you have calculators on your desk? So what's 3b quantity raised to the 4th power? 81 b to the 4th. And I would be multiplying that by 1. We know that's going to stay the same. Okay, look at the next term. Do I do 4 times 3b first or 3b cubed first? 3b cubed. So I'm just going to do 4 times. What is 3b quantity cubed? 27 what? b cubed. Do I need to put times 1? No. Plus, let's go to the next one. I don't do 6 times 3b first. That's multiplication. Exponents come first. What's 3b quantity squared? 9b squared. And then 1 squared is 1. I don't need to multiply by 1. Plus, now I have 4 times 3b times, I'm not going to put the 1 cubed. And then on the end, what is 1 to the 4th? Times 1 is 1. A lot of people don't think I have to put that 1 on. It's just a 1. Well, if I add $1 to your pocket, does that change the amount of money you have in your pocket? Yeah. So yeah, you got to put it. Hello? All right, so we have 81b to the 4th plus 27 times 4 is 108b cubed plus 54b squared plus, see now right now I'm questioning myself. I'm like, is that a 36 or is it a 3b? That's a 3b. So that gives me 12b plus 1. If I find that answer on my multiple choice test, then I probably did it right. Coolio? And then 35 through 39, divide. I'm looking at those, and all of them I can use synthetic division on. Remember to check to make sure you're not missing any terms. Which one would y'all like me to do? 37? Okay, I heard 37 first. I'm sorry. So I'm going to go ahead and set it up. Yes, Joseph? What? No. It'll be split up kind of evenly. Am I missing any terms either in the divisor or the dividend? No, if you are, remember to put a placeholder. Can I use synthetic division here? Yes. Why? What do you mean normal? What's normal? The missing terms, it doesn't matter if it's missing terms. That's not what we're looking for. Anybody know? Your divisor is, no, linear. Yes, linear, right? K is to the first power. And if K had a coefficient, you could, other than 1, you could do it, but it's going to make a fraction, so I would just do long division. Because K is to the first power. If K was squared, it'd be called quadratic. If K was to the third power, it'd be called cubic. If K is to the fourth power, it'd be called quartic. K was to the fifth power, it'd be called quintic. I don't know that. I only know up to 5. Okay, so we're not missing any terms. It's linear. I'm going to do synthetic division. What number goes behind the little house? Positive or negative? Positive. You must change that sign, remember? If you don't, your whole problem's wrong. And then, yes, it's a game show. Come on, move that bus. That's where I get it from. Move that bus. And then I'm going to bring down the coefficient of each term. So what's the coefficient of K to the 4th? 1, and then negative 6, negative 39, negative 19, and 85. And then remember, I skip a line and draw a line. Then what? Bring down the 1. And then I multiply it. 1 times 10 is 10, and it's positive. So my next row, the negative 6 and 10, I just do whatever the sign in front of it is. So negative 6 plus 10 is 4. Anything below the line, we multiply by what's behind the wall. So 4 times 10 is, and it's positive, right? Negative 39 plus 40 is what? Positive 1. 1 times 10 is 10. Negative 19 plus 10 is negative 9. Negative 9 times 10 is 85 minus 90, negative. Now, my answer has to have some K's in it. And so remember, your leading term has a degree 1 less than the leading term in the dividend. So my dividend, the highest degree was 4. So you always reduce it by 1, right? So my very first term is going to be 1k cubed, and then go down, plus 4k squared, plus 1k minus 9. So what does that minus 5 give me? That's your remainder. Do we write R5? No. So now I'm going to write it pretty. K cubed plus 4k squared plus k minus 9, and we're going to write the remainder as a fraction. Since it's negative, I'm going to subtract the fraction bar. 5 goes in the numerator. What goes in the denominator? K minus 10. Boom. And that is my amazing answer. I said we're doing synthetic division. Okay, so let me just repeat what I said earlier. Wednesday, you will be working on your own. So don't go home and finish this. Okay, there's a lot of problems. Don't go home and finish it. You can finish it on Wednesday, unless if you know you're not going to be here on Friday, please, 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 please come prepared to take your test on Wednesday. Otherwise, the rest of us will be continuing to work on the review. The answers are on Schoology already. The review sheet that I posted has the answers on them. So we're going to spend the rest of the day starting the review. Please make sure it's all on a separate sheet. Please make sure you separate your problems so that it's easy for me to see one problem to the next. If you had to grade these, sometimes you would see how frustrating it can be when it all looks like just a big blob of numbers. So please, y'all are doing so well though, separating the problems out, making it neat and legible and easy to grade. So those of you at home, you can log off if you would like. Just continue working on this. Again, we'll work on it Wednesday in class. Test on Friday. Next week, we have no school the whole week, yes. More than likely, it'll just be problems you can use synthetic division, either or, synthetic, or you could use line division, but you could use synthetic division. Okay. Coolio? All right. And I will post this video on Schoology as well, so that if you need to go back and see anything, and then as you know, because I say it a million times, all the other visible videos of individual lessons are already there. And then next module we start is trigonometry.